serosa is right at the edge, right here. That's the serosa up there. Bless you. Okay, this is the prostate, and you have spaces, and the spaces are called alveoli. So, I mean, literally, alveolus means like a space. So it's not only found in the lungs, but alveoli, there are glands in the area. So these spaces are alveoli, and then there's the smooth muscle in between, and so the prostate will contract and squeeze the fluid, the prostatic fluid, into the prostatic urethra. We don't need to know the glands. All right, this is just a higher magnification of what you see here. So you can see the alveoli are much larger here. You can even see some prostatic fluid in there, and the smooth muscle over here. Okay, so this is going to be the penis. Again, this is the glans penis right here, without a D, because it's not actually producing anything. And you have the prepuce or foreskin on the outside of it. So what you're going to do is you're going to have we're going to cut it right here, so you can see these are the deep arteries of the penile arteries. So this is going to be corpora cavernosa, corpus cavernosum, together corpora cavernosa. This is the spongy tissue around it, so this is spongy urethra, and corpus spongiosum. The reason why you cannot have corpus cavernosum around here is because when blood fills up here, it's going to engorge and squeeze everything, and that's what gives the guy an erection. The problem is if you had all the blood in here too, it would squeeze so much, it would squeeze the urethra shut. So when he's ready to ejaculate, nothing would come out. So that's why you have to have a different type of tissue here than you do over here. Way up here, I mean, it looks like a little bug looking at you with the mouth. Way up here, kind of like where they might have some like jewels up here, that would be the dorsal vein and some dorsal arteries. Okay, so this is what it looks like again. Urethra, corpus spongiosum. The deep arteries tend to be right here for the penis, and then you would have the corpora cavernosa and the dorsal veins and arteries. Down, but again, you see how it's like a little bit wiggly there? It's not like that down there. So that's why it's a little bit wiggly over here. So this is the urethra, this is the corpus spongiosum, corpus cavernosa, and erectile tissue over here, and the dorsal artery. Or vein, sorry, dorsal vein. Okay, this one has been flipped. So can you see the little bug looking at you? Okay, so again, this is the corpora cavernosa, urethra, corpus spongiosum, dorsal vein. Okay, again, here is, it's like a monster looking at you, right? So this is the urethra, and this is the corpus spongiosum around it. Okay, now, when we're looking at the helicin arteries, the arteries, it would have been great if they actually showed me, this is red, very hard to figure it out, but these arteries are coming out at you, and they go around into different areas, and they can move around like in a helix, they're not moving, but the blood is moving in a helix formation. So if you can see the name on top, helicin, so that's just adjective for helix. So the helicin arteries are these, and these spaces here where they are found are called sinusoids, or sinuses. I've seen it in different things in the books. This area is called the corpora, or corpus cavernosum. If you write corpora cavernosa, that's okay. Okay, this is the penis where you have the, let me double check. Yeah. This is the sinusoid right here, or sinus. This is the connective tissue. That's why it looks like it's a little bit in blue. This is smooth muscle. And I think that's all you need to know on that one. Wait, let me double check. Hold on. This is a seminiferous tubule found in the testis. Okay? So again, this is the one whole seminiferous tubule. And you need to find the spermatogonia, primary spermatocytes, secondary spermatocytes, spermatids, and I do not see any spermatozoa in there. Okay? If you're never sure, spermatogonia are way over here in this. The primary spermatocytes, can you see that they look like they're undergoing metaphase or prophase. You can see the chromosomes sticking out a lot more. The real small ones are spermatids. Okay, and here this is really well done. So again, this is the seminiferous tubule. This is a be a spermatogonium. This would be a primary spermatocyte, secondary spermatocyte. This is a Sertoli cell, and this is the spermatids would be here, and these are the spermatozoa with their tails. Sertoli cell is sustinacular cell, and it's actually not just this. It's like this whole section. Maybe this is behind it, so it doesn't include these. But it's this whole section here. What it does is it creates a blood-testis barrier so that the immune system doesn't attack the testis. And the reason is that is because when a man is being formed in his mother's uterus, the testes have not produced sperm yet. So the immune system, which is being produced and saying, let's make our checklist of what belongs here, doesn't have testis on the list. That's why later on during puberty, this blood-testis barrier needs to be there. Otherwise, the immune system will say, what? They don't belong in here. They were never here originally, and they would attack it. Okay. Again, this is the head, the mid-piece. I mean, it's really kind of hard. There it is. Mid-piece and flagellum. Okay. Okay. So this is the ovary. This is the medulla, and this is the cortex. And the follicles and the oocytes are developing in the ovarian cortex. Now you have, remember that there are oocytes, and the oocytes are going to develop inside areas that are filled with these big grouping of cells. Those cells are called follicular cells. When there's one layer, it's called follicular cells. When there are two or more layers, they're called granulosa cells, or just granulosa. If you put follicular cells, I mean, I'm not going to mark it wrong, but just to make sure, two or more traditionally are called granulosa cells. So those cells are not part of the oocyte. So we have oogonium, and then inside this follicle, you have a primary oocyte, right, which is 4646. Then it's going to stay like that. Primary oocyte, primary oocyte, primary oocyte. Yes, I know it's a secondary follicle. So primary oocyte, and right here, right before it ovulates, it undergoes meiosis 1, and now a secondary oocyte is what's going to be ovulated. So that is a secondary oocyte. Okay? What's left afterwards, that goes down the fallopian tube, through the fimbriae and through the fallopian tube to get fertilized or to be thrown out. What's left are these granulosa or follicular cells, and we'll go over that. So basically now we're looking at follicular cells. These are primordial follicles here, and you can see that they have little nuclei. This is a primary follicle. You see how these are like just dots, not really organized well. There now is I have one layer of follicular cells. I'm beginning to see that it's starting to form more. So they're starting to form 2 layers. I'm not quite sure how many layers. I can't see it really well. But now they're called granulosa cells. This is a primary follicle, a primary follicle, a primary follicle. Now you start to see the formation of an antrum. As soon as it starts to form, call it a secondary follicle. This one, you can see the antrum is much, much larger, this antrum fluid-filled space. And this is continued from the previous video. So the antrum is getting larger, larger, larger. And so now, even though this is primary oocyte, primary oocyte, primary oocyte, primary oocyte, now this is going to become a secondary oocyte here right before it ovulates, because it's going to undergo meiosis 1. This is called the mature follicle. As you see, a huge antrum, and the bulging at the very edge of the ovary. The fimbriae are going to come by and kind of scrape away at this to help release it. This is the ovulation of the secondary oocyte. You have the corona radiata, which are some granulosa or follicular cells around it. This clear or white powder part around it is called the zona pellucida. Over here you have the theca, which is kind of a protection around there. This is going to go down the fallopian tube, whereas this is going to become, it's going to start to fill up with blood and clot, and then so it's going to close up. So this now is going to be called corpus hemorrhagicum, because it's hemorrhaging inside and then it gets clotted blood. Then it starts to form the corpus luteum. Luteum means yellow. So now this is a really nice big yellow thing which produces progesterone and a little bit of estrogen. This is the corpus luteum, which will continue to produce progesterone for about 10 days. And then it becomes the corpus albicans. Albino is white, so it becomes corpus albicans, and then it will start to turn into atretic little follicles, which will start to fall apart. So right here, again, it's in the cortex, not in the medulla. Primordial follicle. This should not be the primary follicle. This is the primary follicle. That's the primary oocyte. So primary follicle, primary oocyte. This is a secondary follicle. The antrum is already starting to get a little bit bigger. That's still the primary oocyte. This is a mature follicle, a very large antrum, and this is starting to form into the secondary oocyte with its zona pellucida and corona radiata and the theca out here. This is now ovulation of the secondary oocyte with its corona radiata and the zona pellucidum. Corpus hemorrhagicum, corpus corpus luteum would be nice if they made it more yellow. Then it turns into a corpus albicans, which is white, and then it turns into atretic, and then it goes away. The ovary, and you can see various parts of the cortex and the medulla. I really can't ask you about, which follicle it is. It's very hard. This is kind of cool. This is an actual photograph of the ovary releasing the secondary oocyte coming out. Okay, but this is a secondary follicle. The antrum hasn't gotten big enough. So you have, this is in the ovarian cortex, and so you have a primary oocyte, even though it's a secondary follicle. The whole thing is a follicle. Primary oocyte. This is the zona pellucida, which would have been clear in the diagram. This is the corona radiata, which are the granulosa cells that are going to stay with the oocyte when it leaves. These are more granulosa cells that go all the way around. This is the antrum filled with fluid. And then you have the theca. There's an inner and outer theca, but if you just learn theca, that's good enough for me.